Hello guys, welcome to the Logic Prove It concept. Thanks for coming back again. For those that have subscribed and those that are yet to subscribe, please click on the subscribe button and also on the bell beside it to notify you when we drop a new video. Now we have to prove this, that the integral of 6 raised to the power x all over 4 raised to the power x plus 9 raised to the power x all equals 1 all over in 3 over 2 dot tan arc of 3 over 2 all raised to power x plus c. So how can we eventually prove this? It might look impossible, but anyway, step by step we get there. So let's see the first step that we have to use. So the first step says let us divide all through the integral by 4 raised to the power x. So meaning the content of the integral is 6 raised to the power x. Let's divide it by 4 raised to the power x, meaning all over 4 raised to the power x all over 4 raised to the power x plus 9 raised to the power x all over 4 raised to the power x. So this gives us 3 all over 2 all raised to the power x. You agree with me? Because when you factorize the x and later break down with 2, you have this. All over this becomes 1 plus, when you factorize the x and also evaluate the index of 9 and 4, then you factorize, you have what? 3 all over 2 all raised to the power 2x. Then we have this. So the integral becomes integral of 3 all over 2x all over 1 plus 3 all over 2 raised to the power 2x dx. So the next step says let u equals 3 all over 2x. Sorry, 3 over 2 all raised to the power x, not 3 over 2x. So if u becomes this, that means the integral will be transformed into integral of u all over 1 plus u squared. And we have this, don't forget the x. So we cannot evaluate integrals of u with the x, so we have to change the dx to context of u. So how can we do that? So we can say that is this. So u equals 3 all over 2 all raised to the power x. Then the u dx, that's differentiating u, will give us 3 all over 2 all raised to the power x in 3 all over 2. Note this, that a raised to the power x, to differentiate this is going to give us a raised to the power x in a. So it's one of the standard integral, standard derivatives. So now we have this. So meaning du equals 3 all over 2 raised to the power x in 3 all over 2 dx. So that the x becomes 1 all over 3 all over 2 all raised to the power x in 3 all over 2. We can put that into the integral, so we can have integral of u all over 1 plus u squared. The x becomes 1 all over, don't forget 3 all over 2x is u, so we can actually put u here in 3 all over 2. So this can actually go with this. Then the integral becomes integral of 1 all over 1 plus u squared, and dots, we have the u as it is there. So we have the u here. So bringing it here, we are going to have 1 all over in 3 all over 2 du. So this is a constant, so we can take it out and have 1 all over in 3 over 2 integral of 1 all over 1 plus u squared du. Now we've gotten to this stage. What next? Now we can actually use, because in this type of integral, the integral by trigonometric substitution is mostly used to evaluate such an integral. So how can we evaluate that? So very simple. We say that let's u equals tan theta. If u becomes tan theta, that means du d theta is going to be equals to sec squared theta. That means du will be sec squared theta d theta. Let's note this. So let's proceed. On this side, so from which I have this. Now, however, we can still make use of that because du now becomes this, and don't forget that u equals tan theta as we have said. So u squared, that means 1 plus u squared, 1 plus u squared will be equals to 1 plus tan squared theta. And from trigonometric identity, we can infer that 1 plus tan squared theta is the same thing as sec squared theta. Think you get it right? So from there we substitute all this into the integral, which is this. So we have 1 all over in 3 all over 2 integral of 1 all over sec squared theta. Don't forget this becomes this. Then du becomes sec squared theta d theta. So this can actually goes with this. Then we have 1 all over in 3 all over 2 integral of d theta. Oh, d theta, the integral of d theta gives us theta. So we are having 1 all over in 3 all over 2 theta plus c. This is our final answer. I think so. But how can we actually prove it to this extent? So something very simple. So how do we do that? We can see that u equals tan theta. That is, theta will be what? Tan arc of u. Yeah. And don't forget that u still becomes u is still 3 all over 2 all raised to the power x, as we have said earlier. So making use of that in order to manipulate and prove this. So we have tan arc of u, which is the same thing as tan arc of 3 all over 2 all raised to the power x. So then our answer here becomes in 1 over in 3 all over 2 dot tan arc of 3 all over 2 all raised to the power x plus c. So we have actually proved that this integral is the same thing as this. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.